locations. This is -3. This is 3, 6, 9. This is 2, 4, -2, -2. Okay. Now you can take your pretty pictures. I'm ready to go. That's better. See, isn't that easier than having to draw it? Maybe good. Figure it out. So much nicer. All right. Making the sausage is never pretty, guys. All right, so here we go. You guys ready?
That's true.
Yeah. It's never pretty.
Which is why we don't watch it.
That's right. You never watch people making the sausage. What is the limit as x approaches -3? And before you guys lose your minds and go, I don't remember any of this, recall, and this should be on your cheat sheet just in case if you guys need this, limits are about driving cars on roads. So where's the road to the left of -3? It's right here. Where's the road to the right of -3? It's just up here. So here's a car and here's a car, and we're driving at -3. So one's gonna park up here and one's gonna park down here. Are they gonna crash? So if the cars don't crash, does the limit exist? No. That's it.
What about the black dot at the bottom, the
Oh, we'll get
function? Okay.
We'll get there.
That's not in it?
Not yet. What is the limit as x approaches 0? So find the function around x is 0. So here's x is 0. So here's the function around x is 0. Here's the car to the left, the road. Here's the car to the right on the road. Drive those cars at each other. Are they going to crash?
Yes.
Over what y value?
4.
These are all y values. That's the next hint. These are all y values. And I am not looking for them on this graph. If you try to put the locations on here as your answers, I'm gonna mark them all wrong. I'm gonna be like, this is not what we did, guys. I want them as answers over here. They are values to be listed. They are not locations to be pointed out, okay? What is the limit as x approaches 3?
It is 2 and 4.
Does 2 equal 4?
No, it does not exist.
Good. What's the limit as x approaches 6?
It's infinity.
Will those cars crash?
No, it does not exist.
They're gonna drive right next to each other forever and ever and ever and ever. Morning. What's the limit as x approaches 9? I heard it.
0.
Here's the car to the left. Here's the car to the right. Do cars crash over potholes?
Yes.
Yeah, they do it all the time. These easier than you guys remember? Oh, so much more, right? Oh, we're gonna do that too. That's what the piecewise defined functions. Yeah, we're gonna do that too. So limit as x approaches 9 is 0. Okay, now let's talk about one-sided limits up here. What's the limit as x approaches 3 positively? Which side are we coming at it from? Positive
the
means the
Right-hand side. So
Yes.
it's only 2?
4 is the answer, or no, not 4. Not 4.
It's 2.
It's 2. If we're coming at it from the right-hand side, we're going to end up at y equals 2. If we were coming at it from the negative side, we would end up at 4, Alex. Remember now? Good. Okay. So positive means right-hand side, negative means left-hand side. Why? Because this is positive x, that's convention, so that's your right hand. This is negative x, that's convention, that's your left hand. Okay? So left card, right card. Okay? Now let's do the functions. Before that, let's do the infinities. What's the limit as x approaches negative infinity, guys?
X approaches.
Try again. No.
What is -2?
Yeah. It's -2. Or another way to say this is, does y have a limit as x goes off the page to the negative infinity side? Is y limited? Is
No.
y limiting itself? To what number?
Infinity. Negative infinity.
-2.
Negative 2.
Where the hell are you? There you are. What about on the positive side? As x goes to positive infinity, is y limiting itself? No, what's it doing? It's going to negative infinity. It's not limiting itself. So that's D and E. So as x gets really, really big, y is getting really, really big in the negative direction. It's growing without bounds in the negative direction. It's not limiting itself. Emily? You were like, no. Talk to me. Where'd I lose you?
I don't, why doesn't the dashy line do anything?
It does mean something. We got the smack stick. And not smack, but gently put something there. Imagine your finger is the function. So as x moves out towards infinity, here's the behavior of the function, right? So as we go out, this is my limiter, my horizontal asymptote. So I'm stuck on that horizontal asymptote forever and ever. So I'm stuck on y equals -2, right? So